So we have started with this chapter, carbon and important element, yesterday. We have completed till diamond. We studied about the structure, properties, and uses of the diamond, how carbon atoms are connected in diamond. Each carbon atom is tetrahedral, is surrounded by 4 carbon atoms. Have you understood this part? Any doubt is there here? Also, we have studied the properties of diamond along with its uses. Okay, no doubts, then we are going to proceed with graphite. So again, graphite is an allotrope of carbon. Means what? It is one of the form in which carbon exists. So talking about the occurrence of graphite, where graphite is found. So it is found in the natural state in Russia, New Zealand, America, and India. So you might be knowing very well that the lead which is used in pencil for writing, right, that is made up of graphite. Okay, how it is made? It is made by mixing graphite with clay. So that lead is actually made up of graphite. Then talking about the structure again, since this is an allotrope of carbon, it is completely made up of carbon. No other element is used here. In the diamond also we have studied that it is completely made up of carbon, and your graphite also it is completely made up of carbon. No other element is introduced here in the structure. If you carefully see the structure which is shown in front of you, this carbon is forming hexagonal rings. This carbon is forming hexagonal rings. Now, what do you understand by hexagon? What is a hexagon? How many corners are there in hexagon? 6. Yes, very nice. This is a hexagon, right? So in graphite, in structure of graphite, carbons are arranged in the form of hexagonal layers. Okay, hexagonal layers. If you see this first layer which is shown here, see this layer. This layer is consisting of hexagonal rings, right? This layer consists of hexagonal rings. So many hexagonal rings are connected with each other. In this way, the structure is not ending here. The structure is continued from this side also and from this side also. Okay, so this is one layer. This is first layer. This is first layer which is made up of hexagonal rings. Then again, you can see here. This is the second layer. This is the second layer. Again, the second layer also consists of hexagonal rings. So this graphite is actually a layered structure, one above the another, one above the another. Not only 2 layers are there. There are so many layers available in graphite structure, and each layer is separated by a particular distance. You can see this space which is shown here. This space. Okay, this is an empty space. This is empty space. No atom is present here. It is an empty space which is present between 2 different layers, and these layers are attracted by weak force of attraction. Okay, so here you can see, take any of the carbon atom, take any of the carbon atom from these layers. Suppose we are taking this carbon. Okay, suppose we are taking this carbon. Now tell me, this carbon is connected to how many other carbons? Tell me how many other carbons are directly connected with this carbon. See carefully and tell me how many other carbons are directly connected with this carbon. Yes, very good. Other students, try to reply. See the figure and tell me how many other carbons are directly connected with this carbon which I have shown you with the red mark. Directly connected students, I am asking directly connected. डायरेक्टली कनेक्टेड मतलब बॉन्ड से कनेक्ट होने चाहिए. See, this carbon is directly connected to this carbon, to this carbon, and to this carbon. Means how many carbons are directly connected? Now say three carbons, right? Three carbons. One carbon. You take any carbon now. Any carbon you take. Any carbon, if you take, that carbon is connected to three other carbon atoms. Okay. But in case of diamond, now in diamond, tell me each carbon is connected to how many carbons? Now suppose you take this carbon and tell me this carbon is connected to how many carbons? Yes, very nice, Hamza. 4. Okay, so this is the difference between graphite and diamond. That in diamond, each carbon is connected to 4 other carbons, but in case of graphite, each carbon is connected to only 3 other carbons. Now, one layer of graphite is called graphene. Since we have studied that graphite is made up of so many layers, so if we talk about one layer, one particular layer, then this layer is known as graphene. And if many layers are together present together, then they are known as graphite. If we are talking about only one layer, then it is known as graphene. Okay, students, have you understood this graphite? Okay, then we are going to proceed. See, one activity is given. Okay, that regarding syllabus we'll talk at the end of the lecture, students. See this activity is given. What apparatus you need is you need a pencil, you need electrical wires, battery or cell, small bulb, water, kerosene test tube, lid, pencil, etc. Okay. Now see what is the activity given. Remove the lid from a pencil and fill it with your fingers. What color is it? This we know very well. We are in daily use of pencils, right? So no need to do this. Try to break the lid with your hand. Okay. So don't spoil the pencil. We know that it will going to break. Apply the apparatus as shown in the diagram. Start the electrical current in the circuit. Observe. What do you find? So see this electrical circuit which is shown here. What you have to do? You have to take a pencil which is having a tip from both the sides, and then you have to connect wire to it on both the sides. Then you have a bulb, you have a cell. Okay. And you have to see what will happen. So this you can try it at your home also. It is quite simple. Just take a pencil, bulb will be there. So many toys and all those things are there which consist of small bulbs. So you can use that bulbs, and cell is definitely very easily available. So you can try this experiment and tell me what happens. Next is properties of graphite. So how is graphite and what are the properties? See, graphite found in nature is black, soft, brittle and slippery. So we understood what is black, what is soft. What do you understand by brittle? What is brittle? What is brittle? I have explained you this brittle many times. Suppose take the example of chalk. Okay, piece of chalk. You have any piece of chalk, and what you do? You hit that piece of chalk with a hammer. Okay, hit the piece of chalk with a hammer. What will happen? Tell me. If you hit this piece of chalk with a hammer, what will happen? It is going to break down into smaller pieces or very small particles. It will get converted into powder, right? Yes, chalk will get converted into powder. This is the property of non-metals. Non-metals usually when heated with a hammer or applied pressure, they get converted into small particles or they get converted into powder form. So the same thing is going to happen with the graphite when you hit the graphite with any hard material, it will get converted into powder form, and this property is known as brittleness. Okay. Next, inside, yes, hard but easily broken down. But this graphite is not that hard. Okay, it is slightly soft and slippery. You don't understand what is mean by slippery? Anybody knows what is slippery? See, take the example I'm telling you. Suppose you have a floor which is made up of tiles in your house. Okay, the floor which is made up of tiles, and what happens that you are having water on your foot. Okay, so what will happen? You will feel some slipperiness. है ना, जब फिसल जाएंगे हम टाइल से That type of nature is known as slippery. Ha, that is known as slippery. So this graphite also has that type of property. Now, second property, inside each layer of graphite, inside each layer of graphite, free electrons move continuously within the entire layer. Free electrons move continuously within the entire layer. That is why graphite is a good conductor of electricity. So we have studied that for conduction of electricity, for electricity conduction, free electrons are required, right? For electricity conduction, free electrons are required. So if graphite is containing free electrons, then it will act as a good conductor of electricity. Any substance which is having free electrons is going to act as a good conductor of electricity. So this graphite acts as a good conductor of electricity because of the free electron. Okay, and this free electron is going to move in the layers. So the free electrons are not going to jump from one layer to another because here we know that this graphite is a layered structure. So if electrons are present here, so that electrons are going to move in this layer only. If electrons are here, that electrons are going to move in that particular layers only. Okay, they are not going to jump from one layer to another because so much space is available in between. These layers are separated with so much space. So whatever free electrons are present, that free electrons are going to remain in that layer only. Okay. Next, due to the layered structure, graphite can be used for writing on paper. So we know this property of graphite, that why this graphite is used in lead, because of the layered structure. The density is given. Graphite does not dissolve in most of the solvents. Okay. So this is insoluble in most of the solvents. You know now what is solvent? Okay. Next, uses of graphite. So first use is making lubricants, second carbon electrodes, third writing. We know that this is used in pencils. Next is it is used in paints and polishes. Okay, then graphite is used in the arc lamps which give a very bright light. Now I know that you might be not aware of lubricants, right? What is lubricant? You might not be knowing. So you know that for the proper working of machines, we regularly oil the machines, right now? For proper working of machines, we regularly apply or put oil in the machines. Why we apply oil in the machines? Any reason here? Anybody knows? Why we continuously oil the machines? Oiling of machine is done. Why? To avoid the friction between the machine parts. to avoid the friction between the machine parts, because when machine so to avoid the friction between machine parts, what we do is we apply the oil, or sometimes grease is also applied, because if machine parts come in contact with each other, what will happen? They undergo friction. They undergo what? Friction. Because of friction, the parts of the machine gets damaged. So to prevent this damage, oiling is done. So lubricant is also the same thing to prevent the friction. ठीक है, जो मशीन के पार्ट्स होते हैं वो जब क्लोज आएंगे तो उनमें friction होता है, and the parts get damaged. So because of that damage, the machine may get destroyed. So this type of graphite as a lubricant is used in machines or in any other places to avoid friction. Now this carbon electrodes, this is used in electrolysis, which is a type of chemical method for production of compounds. Okay, for that carbon electrodes are used. Electrodes means carbon will be present in the form of rods. Carbon is made into rods and dipped into the electrolyte. I will show you the apparatus, how the apparatus is. So this is the apparatus in which these carbon rods are used, which are connected to electrical supply. Okay, इलेक्ट्रिकल सप्लाई पे कनेक्ट किए जाते हैं. So these are carbon rods. These are carbon rods which are known as carbon electrodes, which are used in chemical reaction. तो यहाँ पे जो भी लिक्विड फिल किया जाता है उसमें केमिकल रिएक्शंस होती है. Okay, that liquid is known as electrolyte. And this carbon rods helps in the reaction. Okay, these are known as carbon electrodes. Any doubt here? Okay, next is what? Next is fullerene. So again, this fullerene is another allotrope of carbon, and it is said that it is rarely found in nature. Okay, it is not very common in nature. बहुत कम पाया जाता है. So it is found in soot and in interstellar space. So interstellar space is not here. It is outside the Earth, and in the Earth, inside the Earth, it is found where in the form of soot. Okay, means very rarely, in very less proportion, it is obtained. जमीन के अंदर जो भी राख वगैरह होती है वो सब राख वगैरह में फ्लोरीन थोड़ा सा पाया जाता है, इन वेरी रेयर प्रोपोर्शन. So this example, first example of fullerene, that is C60. What is this C60? See this structure. This is fullerene. The structure which is shown here. सूट पहनने वाला नहीं, राख वगैरह जो होती है ना, राख, धूल, मिट्टी, राख, उसको सूट बोला जाता है. That suit is different. That is cloth. That is different. Yes, ash you can say. Okay. Now this is a fullerene. So this is C60. C60 means what? Yes, 60 carbon atoms are present. Okay, C60 means what? There are 60 carbon atoms which are present here. So not only C60, this fullerene can be made up of different proportions. Like here, see, it is given C60, C70, C76, C82, C86. So these are the different forms of fullerene which are available, which depends upon the number of carbon atoms. Okay. So to see the structure very carefully, you can see there are hexagons as well as there are pentagons. Can you see? See the structure. Can you see hexagons and pentagons? See, this is hexagon. This is hexagon. Hexa means what? Five. Sorry, hexa means six. So this is a six-membered structure. This is a six-membered structure. This is pentagon. Penta means five. This is five-membered structure. Five corners, five sides. Can you see? So this entire fullerene is made up of hexagons as well as pentagons. Okay. And the number of hexagons and pentagons in particular type of fullerene is also fixed. Next we are going to proceed with the properties and uses of fullerene. Properties and uses of fullerene. Now see properties. Molecules of fullerenes are found in the form of buckyballs and buckytubes. Okay, these buckyballs, because if you see this fullerene, it looks like a ball, right? It looks like a ball, so it is also known as buckyball or buckytube. Okay, this is actually a buckyball. Buckytube form is also available. It is also termed as a soccer ball. So this is the buckyball structure of fullerene. So see there are 300 to 900 carbon atoms in one molecule of fullerene. What is the range? It is 300 to 900 carbon atoms. And the fullerene which we have seen just now, that consists of how many carbon atoms? The fullerene just now we have studied that consisted of how many carbon atoms? 60, right? This structure which I have shown you, this buckyball structure. C60 it is written. See here, buckyball C60, right? So this fullerene consists of 60 carbon atoms. In a similar way, it is written that this 60 carbon atoms is not fixed. Okay, this 60 carbon atoms is not fixed. There are as much as 900 carbon atoms can be present in one molecule of fullerene in such a vast structure from 30 to 900. Okay, then fullerenes are soluble in organic solvents such as carbon disulfide and chlorobenzene. What is actually now organic solvent? What is organic solvent, students? Solvents which are made up of carbon. Solvents which are made up of carbon and hydrogen are known as organic solvents. Okay. Yesterday also I have told you what do you mean by organic and what do you mean by inorganic. So the compounds which are made up of carbon are known as organic. Okay, and compounds which do not contain carbon or any other elements other than carbon, they are known as inorganic. So since carbon is organic compound, sorry, fullerene is an organic compound, right? Fullerene is made up of what? Carbons. Fullerene is completely made up of carbon. So it is an organic compound. So it is going to dissolve in organic solvents only. And the example of organic solvents is also given: carbon disulfide and chlorobenzene. So if you want to see this molecular formula, sorry, this is carbon disulfide CS2, then chlorobenzene. This ring in organic chemistry, this type of ring, it is known as benzene. And now when chlorine is attached here on the top, it is known as now chlorobenzene. It is known as chlorobenzene. Okay. Okay. Now the last part of this crystalline forms, that is the uses. So uses of fullerene. So fullerenes are used as insulators. Fullerenes are used as insulators. So what do you mean by insulator? What is insulator, students? See, if we talk about conductors, so tell me what are conductors? You should be aware now what is insulator, what is conductor. So many times we have discussed this thing, and every time I ask, you don't say anything. Now tell me what is conductor. Say what is conductor. Substances, substances through which electricity can flow. These are known as conductors, right? Any substance through which electricity can flow. These are known as what? Conductors. Metals are usually good conductors. Right, now what about insulators? Insulators are those substances which do not allow the flow of electricity. Insulators are those substances which do not allow the flow of electricity. Okay, means they do not contain any free electrons. Because they do not contain any free electrons, electricity cannot flow through them, right? So in the structure of fullerene, free electrons are not present. Since no free electrons are present, they are not going to conduct electricity, and they are known as insulators. They are known as insulators. Okay. Now, fullerenes are used as catalyst in water purification. So again, what is catalyst? Catalyst is a substance which increases the speed of the reaction. Okay, or which helps the reaction to proceed faster. Catalyst is a substance which increases the speed of the reaction or helps the reaction to proceed faster. Okay. Third, last use of fullerene. At a certain temperature, fullerene exhibits superconductivity. Okay, temperature range is given normally at the room temperature when we talk students. So at room temperature, fullerene is acting as an insulator. At room temperature, fullerene acts as an insulator, but at a certain temperature range, okay, some temperature range is given, and that temperature range, this fullerene acts as a superconductor. मतलब normal conductor से भी बहुत ज़्यादा conductivity. Super means very high conductivity. Okay. So this fullerene acts as a superconductor at a particular temperature. Understood? Now just go through the part which we have discussed just now and tell me whether you have any doubt. Just go through the part, everyone. And whenever I give you any definition or any example, try to write it down in your textbook with pencil, because every time I make you understand and after 2 or 3 days you again forget it. So whenever any meaning or something is told to you, you should write it down with the pencil in your textbook. So it will help you again when you read it. Whenever you open your book and when you don't understand anything, so that will help you to understand better way. Other students, are you listening to me? No, not a single reply from other students. Okay, no doubts. Okay, no doubts. Then we are ending the lecture. This amorphous or non-crystalline part we are going to start in the next class. Okay. So we have completed with all the crystalline forms, their properties and their uses. Non-crystalline will be starting in the next class.